Recently, I made a video explaining the physics of wires, but I realized I didn't answer the question that a lot of people want to ask. Does electricity travel inside or outside a wire? To answer this question, we need to define what is electricity. I'm going to use this definition, a phenomenon in which motion of charge carriers transfers energy from one place to another. So there's two parts, motion of charge carriers and transfer of energy from A to B. Now it's important to note that the charge carriers themselves don't have to move from A to B in order to transfer energy or information from A to B. If we look at electrons in a circuit, they're drifting very slowly, typically less than a millimeter a second. If we had to wait for electrons to flow through the length of a circuit, we'd be waiting a long time. It's even more obvious if we consider alternating current. Here the electrons aren't really travelling down the wire at all. The direction of drift keeps alternating, so there's no net movement of electrons. It might seem strange that this carries energy down the wire, but think about a wave on a string. Each part of the string is just moving back and forth, in this case up and down, but energy is carried down the length of the string. The same is true for water waves, the same is true for sound waves. In fact, if you think about it, in all of these waves, the wave is actually propagating via electromagnetic forces between particles. So coming back to the definition, we have motion of charge carriers, and we have transfer of energy from one place to another. These are related but separate. Now obviously the motion of charge carriers is inside the wire, but it's only over short distances. The transfer of energy is down the wire, but it's in the electromagnetic field, which is actually mostly outside the wire. That's the short answer. But you might ask, if the electromagnetic field is caused by electrons, why don't we just account the energy to the electrons inside the wire? So, as far as we know, it is true that all electromagnetic fields are the result of charges and currents, where currents are just moving charges. This is expressed in Jefimenko's equations. We can express electric and magnetic fields in all space purely in terms of charges and currents at some point in the past. If we take this worldview, we don't need to say changing electric fields produce magnetic fields or any of that mumbo-jumbo. The fields everywhere can be calculated from past charges and currents. So why worry about electromagnetic fields at all if charges and currents are more fundamental? Here's the problem. I hold up this solar panel to the sun and I get some energy. Where did that energy come from? You could say, well, I know Jefimenko's equations. The electric field in this panel was caused by some current on the sun 8 minutes ago. But that's a horribly non-local way of looking at it. What I want to know is where did the energy here come from now? It's more sensible to think about what that current on the sun can affect at a specific time. After 3 minutes, it can affect something on Mercury, potentially giving it some energy. After 6 minutes, it can affect something on Venus, and so on. The wave of potential effects is a wave that travels continuously through space-time. We call it an electromagnetic wave. It's necessarily carrying energy because to affect something we need energy. Now coming back to electric circuits, it's similar on a much smaller scale. Fundamentally, a circuit consists of moving charges. But most of the time what we care about is not the jiggling electrons, which only move over small distances. We care about the wave of potential effects caused by those jiggling electrons. And that's necessarily where the energy is located to cause those effects. Inside wires, the electromagnetic fields are nearly zero, for reasons I explained in my previous video. Outside the wires, the fields are large. Energy flow is directly related to the field magnitudes, so that implies that most of the energy flows outside the wire in this glowing purple region. We can show that that energy flow is the same as the circuit power. Now, you might still be thinking that this energy flow in the electromagnetic field is just a mathematical construct. We could just as well attach that energy to the charge carriers. But then where does the energy materialize from in the solar panel example? And if we consider deeper physics like general relativity, we know that energy density curves space-time. So the choice of where to account for energy is not really arbitrary. It has physically testable implications. I hope you found this interesting. As usual, please like and subscribe for more.